Hello, class. This will be the last of the recorded lectures for the laws of sines, section 3.5. In this, we will walk through the what the book calls the ambiguous case when you have side, angle, side, where the angle is opposite of one of the sides. So by our definition, the side that is opposite of that angle is side A. And from the previous lectures, we talked about the different conditions with regards to possible solutions. And so let me just review that again real quick here up on the slide. So here's angle A, which is in the lower left-hand corner, and the opposite side is side A. Now, when side A is less than side B, then there is a couple possibilities. One of them, there could be no solution. And one of them, which is called the ambiguous, is there are two solutions. And the way that that works is, let me show you the solution and then we'll work through the problem. And so here's the problem we're going to walk through. Bang. And so what you'll be given is this angle of A of 43.1 degrees and A of 186.2 and B of 248.6. And you can see, depending on the value of angle B, there's two possible solutions. One of them is angle B is between 0 and 90 degrees, or remember that's called acute angle. And the other would be in the second quadrant between 90 and 180, and that's called an obtuse angle. And both of those are possible. And unless you're given more information, you don't know which one is right. And so this is the only situation that this occurs. So there are, I think, one or two homework problems that possibly have this ambiguous. So why don't we walk through this example? So again, what we're given is angle A equals 43.1 degrees. Length B is 248.6. And length A, which is the opposite from angle A, is 0.2. And so I'll just draw the triangle the way we normally draw it. And so again, this is angle A here. And so our B value here is 248.6. And our A value that's right here is 186.2. And you see that 186.2, A is less than B. So we have a possibility of two solutions. So again, this is angle A and this is B. This is going to be angle B because it's across from that side. So this would be C and this would be angle C here. And so how do we do this? Well, we are given A, right, and little a, and then we're given side B. So we would start with this law of sine identity, right, over B. And so we have three of these four, right? And so let me just plug these in for you. Well, let me solve for B first. And so again, that would be, whoops, wrong B. I want to solve for the angle. That's what we don't know. Try again. So sine of B equals B times sine of A, all divided by A. And so when you plug this in, this is what you get. You get 248 and some change times sine of 43.1, all divided by 186. And you would think that, hey, you just get your calculator out, and that is true. And you would find what the value is, because B would be sine inverse of this mess, right? So if you get your calculator out and you find this number, you would see it would be 0.9122. And then we take the sine inverse of both sides to calculate B. And if you hit your calculator, it would be 65.8. And then you say to yourself, that should be the answer. And it is one of the answers. That's the good news. But because this ambiguous idea, where because this side is less than, the A side is less than the B side, this angle could occur in the first quadrant or it can occur in the second quadrant. And remember, sine is positive in quadrant 1 and quadrant 2. That's our quandary, right? And so that's the ambiguous part of it. So how do we find that other angle? So let's call this B1. So let me put up here, B1 is 65.8 degrees. So how do we find B2? Well, remember, if we think about, remember that reference angle we always talked about? So this would be 65.8 over here. So this is the second angle we want to measure, B2. So B2 would be 180 minus 65.8. And so that would be 114.2. So B2 would be 114.2. So you see that depending on what angle you use for B, you're going to get two different solutions for the values of C. So what do you need to do? You need to walk through both possibilities. And so let's walk through possibility 1 first. Okay, I erased all that and resumed the recording. So let's deal with B1 first. So now we know B1 is 65.8. So what's C1? Well, you do it the same way. It's 180 minus angle B, 65.8, minus angle A, which is 41.3. And if you did that, you would get 71.1 degrees. How do you find little c1, which is the length, right? So little c1, now you'd use, see, what did I use in my notes here? Sine of A still. So it'd be sine of A over A equals sine of C over little c. And so when you solve for this, little c would equal A sine of C, all divided by sine of angle A. And so you just plug those in. But now remember, this is C1, so this is little c1. And so when we do that calculation, we use the C1 angle, so it'd be A sine of, whoops, try that again. Let me put the number in now. So A again is 186.2, and this would be sine of the C angle, which is 71.1, and then we divide by the sine of the A angle, which is 43.1. So if you got out your calculator, you would see C1 would equal approximately 257.8. And if this was feet, that would be feet. If it was inches, that would be inches. Okay, so option 2. Well, option 2 would be, we set B2 equal to that angle in the second quadrant. So you walk through the same thing. Possibility of C2 is 180 minus 65. Oops, wrong C. The new C, C2, which is 114.2 minus A, which is 41.1. And if you did that calculation, you see that's a lot smaller, 22.7 degrees. So now if you want to calculate little c2, we have this same equation here, except you plug in c2 instead of c1. So again, that would be A times sine now of c2 over sine of A. And so you see that when we plug that in, you would get 186.2 times sine of this case 22.7, all divided by sine of 43.1. And if you did that, you would see this is going to be a lot smaller. It's 105.2. And so it's just a systematic approach, you know, and the key is you have to recognize this criteria, is that the opposite side is less than the adjacent side. When that occurs, you have to go through those two iterations. And again, just to reiterate what the triangles look like, and I specifically took this right out of the book because it has nice drawings. And for those of you that have been watching these lectures, you can tell I'm not a very good drawer. But you could see here's our C1, right? Where B1 is less than 90. So you can see C is quite a bit bigger. And then you can see here where B is greater than 90, right? And you could see that the C2 angle is quite a bit smaller, which ends up that the C2 length is quite a bit smaller as well. Just to, I don't know if this is going to be a refresh of anybody's memory, or it might be something new to you, but it's a very unique thing when you have angles. When the biggest angle, that opposite side is always going to be the longest. And so that's another way of looking at it. The smallest angle is going to be the opposite of that smallest angle is going to be the shortest length. And the middle one is going to be the middle length. And if you go back and look at these triangles, you could see what I mean. And so you could see A is 43, and that's the smallest one in this group, right? And so you could see it's the smallest length. The next one is B, which is 65.8, and that's the next biggest. And the biggest angle here is C1, and you see that's the longest length, the opposite. Well, here you could see C2 is the shortest, the smallest angle, so you could see C2 is the shortest of the three in this case. So it's quite interesting, and you'll be able to, if you remember that, you'll be able to kind of look at your answers and see if they make any sense or not as well. So this ends the recorded lectures for the laws of sines, section 3.5. Next on our hit parade is the laws of cosine.